right, you can have your books off your desks for now. Just fill out a blank sheet of paper if you would, please. Have out your protractor, have out your compass, and get everything else off your desks. Make sure water bottles are off your desks. And if you would, with your protractor, just draw, using the straight edge of your protractor, draw some acute angle. Doesn't really matter how big, don't measure it or anything, just make some random acute angle, but make it nice and neat by using the straight edge of your protractor to draw it. So draw two line segments that meet at a vertex. And we will name the angle P-O-W. Pow. Or if you go the other way, whop. Put them together, pow, whop. Anyway, it's a very aggressive angle. All right, what I want you to do now is measure the angle you just drew. You all drew different sizes of angles. Measure the angle that you just drew.
Here we go.
Remember, many of you are going to have to extend this side so you can read it. If you have a metal protractor, you're going to have to extend this side so that it'll go far enough out for you to read it. So extend as necessary and measure your angle. Mine, for instance, is either around 120 or around 60. Obviously, class, it should be
60.
Close to 60. I'm going to say if 70's here, 50's here, it's on the 50 side, so it's a little less than 60. I'm going to say mine is 59 degrees. You measure yours and see how big it is. How many had an angle that you drew? When you drew it, it was in the 20s. It was a little angle. How many went in the 30s? It was a little bit big. 40s, kind of a medium-sized angle. How many was in the 50s, like mine was? How many in the 60s? How many when you drew it, you just barely drew it acute? It's in the 70s or 80s. Did anyone have over 90 degrees?
Wait, no.
Better not have, not if you're doing an acute angle. All right, now if you would, I want you to draw an angle, but this time, draw the line and make, if you would, the angle like this. Use the straight edge of your protractor to draw the angle like this.
Wait.
What kind of angle do we have, class? An obtuse angle. But we're going to have to be careful which scale we use now as we read it. Again, I'm between 120, 130, or 50 and 60, but I need to think of it as between 120 and 30. Mine's 126 degrees. So measure the angle that you drew, see how big it is. You may want to actually use the straight edge to extend rather than trying to eyeball, just so you can be accurate. I'd hate for you to be just a little bit off because you tried to cheat the system a little there. All right. Now if you would use your bless you. Now if you would use your protractor to draw a 115 degree angle. Use your protractor to draw a 115 degree angle. This time all of our angles will look the same. Last couple times we've all had different sizes of angles. And using just the straight edge now of your protractor and your compass, we're going to construct another angle equal to your 115. Now we're going to construct an angle equal to 115. Take just a moment to do that. Construct an angle equal to your 115 degree angle using your compass and the straight edge of your protractor. I'm sorry?
Your first one? Was that the first one?
No, that's my third. Yes, ma'am. Go around. When we copy an angle or construct an equal angle, class, we start by drawing a line. Then I draw an arc with my compass. We put the point of the compass on the vertex and make sure the arc goes through
the line.
both sides of the angle. All right, so draw an arc so it goes through both sides. of the angle. Once you've made that arc, what do I not do?
Close the
Do not close the compass, but instead just take the point of the compass and put it
other line.
on the other line. Specifically, where on the other line?
Vertex.
Well, it's not a vertex yet, it's just an end point. You're gonna put it on an end point. It's gonna become the vertex though, and we make a, should I make an arc like this?
No.
Why not?
Because it's too small.
It's too small. I've got to have an arc at least that big. So make sure when you make your next arc, make it nice and big. Do I need, class, to go very far down here like this?
No.
No, but I do need to make sure I at least go far enough to do what?
Make the other angle.
Intersect that line. I've got to at least intersect the line. You don't need to do a whole lot down here, right? None of this extra here is necessary. Just make sure you get through the line. Then what do I do with my compass, Sam?
We're gonna go to the other line
Go over back to the angle over here.
and measure the two intersecting points.
Good. Find these 2 points where the arc intersects the sides of the angle. Put the point of the compass on one. Open it up until it just, look too far, just perfectly reaches the other side. And then don't close that compass. Bring that measurement over here, class. Where does the point go now?
On the line.
Where the intersection is. Just like we put on this intersection, we're going to put it on this intersection. And we're just going to reach across and make that arc. And then, class, we get to play connect the dots. Just like back in, just like kindergarten, except we're not making pictures of like elephants and giraffes and such. And there's our copied angle. Now we had this, even before I started going over it with you. Any questions on these constructions or drawings? Yes, ma'am.
I did it and I got little. No, I got.
You've got a couple different arcs going here, so the thing I would say is, for smoothness sake, when you put it down, just nice and smooth, right? So instead of like trying to go back and forth with it, put it down, go nice and smooth. Because you've got so many different like messy arcs going, it's hard to know where to measure perfectly, and that probably is why you're just a little bit off. All right, so let me show again. It's going to be hard on the chalkboard. I showed this on the tutorial video I put on YouTube for those watching. But imagine this is on a piece of paper. I'm going to try to do this, but it's hard against gravity. Instead of like doing like a back and forth like this where it gets a messy line, just make sure you go through one time. And when I was showing Jalen just a moment ago, I actually just rotated the paper and let it do that. I obviously can't do that with the chalkboard. Just let it go nice and smooth that way. All right, clear desks, except for another blank sheet of paper now. Put that messy sheet of paper away. Take out another blank sheet of paper. Of course, keep out your compass, keep out your protractor, keep out your pencil. We're going to take a quiz, give you an opportunity to show me what you know. All about angles and such. So, just all about angles. All right, so desks are clear except for a clean sheet of paper, water bottle, clean sheet of paper, pencil, compass, protractor, possibly an eraser. Everything else away. This is quiz 15 for those watching on YouTube. Quiz 15. Yes, ma'am. I'll sharpen it for you while you're doing the rest of the quiz. All right, first and last name in the name spot. And today's date in the date spot, it is 11/17/23 as we record. 11/17/23 as we record this. Let's take a look at the quiz together very quickly. Numbers 1 through 7, just answer the questions. These are all things that we've talked about considerably. Numbers 8 and 9. Numbers 8 and 9, you're going to use your protractor to measure the angles. You're going to have to extend the sides. Now, everyone in here now has a clear protractor, I notice. Okay, those people who have the metal ones have changed over. If you're watching and you have a metal protractor, look at number 9. The rest of you, this is just insightful, so you can look as well. Look at number 9. Do you realize that the horizontal line on number 9 is not going to be able to extend far enough for a metal protractor? So then extend the one that's going upward. Extend that one and use that as your starting side. Okay, so that's a tip for those watching on YouTube who have metal protractors. Those of us in here all have clear ones. You should be okay as you extend sides. And obviously number 10, you have just that one construction there. All right, you may begin. Make sure you keep your eyes on your own paper. It's going to be a little more challenging with the constructions and drawings and measurings and all that to cover your work. So as you can cover, but make sure you're keeping your eyes on your own paper, not looking at me, not looking around the room. Eyes on your own paper. As you finish, pencil down. Turn your paper over and just sit quietly. Make sure you're keeping your eyes in front of you or down at your desk. No reason for me to suspect you may be looking around. few students already finished. Still have a couple more minutes though to be finishing up, so take your time, make sure it's neat, very accurate. Once you finish, you sit quietly. If you want to draw circles on your cover sheet, you may do that. Yeah, that's another minute now to be finishing up. No, you don't have to actually measure the angle at the bottom, number 10. You're just constructing one equal to. You don't have to measure it with your protractor or anything. If you want to, you can. It's not necessary. Right, 30 seconds more, and I'll be collecting them up from you. Got a nice snowman going on one cover sheet now. Just let me take it. Go take your textbooks out now, if you would please. Turn to page 166. Page 166. Unit numbers 1 through 14 on your the homework section on page 166. Yesterday we began looking at three-sided polygons. Class, what do we call a three-sided polygon? Triangle. We talked about different kinds of triangles. Number 1 in the homework asks this. An equilateral, notice the spelling, triangle has how many equal sides? Michael? 3. An obtuse triangle, number 2, has how many obtuse angles? Luciana? 1. Number 3, a right triangle has how many acute angles, Bryson? 2. How many right angles in a right triangle, class? 1. You can never have more than 1. What about an acute triangle? I didn't ask about it. What about an acute triangle? What's it going to have in it, Jalen?
It's going to have 3 acute angles.
3 acute angles, very good. What about a triangle that only has 2 equal sides, class? If it only has 2 equal sides, it's not equilateral, but we do have a special name for it still, class? Isosceles. What about a triangle with no equal sides? What do we call that, anybody? Scalene triangle. Number 4, asks you to find the missing angle of each triangle. What do we know about the 3 angles of any triangle, Sam?
Okay, you'd add up to 90.
Ooh, they don't add up to 90.
180.
They add up to 180 degrees. By the way, would we say then, class, that the angles of a triangle are supplementary?
Yeah.
No. But why not? They add up to 180, right, Jalen?
Because they're not in a straight line.
No, that's not why. What do you think, Elaine?
There's more than 2.
There's more than 2. Supplementary is specifically 2. I remember thinking that as a junior high kid. Well, why don't we just say the angles of a triangle are supplementary? We sound smarter. No. Because supplementary means 2 angles that add up to 180, so not 3. So, yeah, I think I asked that question of a math teacher at one point. I thought I was smart, and I found out I wasn't so smart. Anyway, so they all add up to 180 degrees. So on number 4, we're given 2 angles, 110 and 10 degrees respectively. What about angle Y, Sam?
60.
60 degrees. What about on number 5, the missing angle L, Ben?
20
20
degrees.
degrees. Very good. Number 6, what about the missing angle T, Kirsten?
110 degrees. Oh, wait, no, 100 degrees.
100 degrees. Good. We already have 80 degrees there, so we only need 100 more to make 180 degrees. Number 7, it says to identify the type of triangle being discussed. If the angles of the triangle measure 20 degrees, 70 degrees, and 90 degrees, Griffin, what kind of triangle do we have?
Right triangle.
Right triangle. How do you know?
Is 90 degrees.
Because one of the angles was 90. There we go. Number 8, sides of a triangle are 3 feet, 15 feet, and 13 feet. Corey?
Equilateral.
What does equilateral mean? Griffin, what does equilateral mean?
It's all the sides are equal.
All the sides are equal. Well, Corey, they just said the sides are 3, 15, and 13. So they're not all equal. In fact, they're all different. What triangle has all 3 different sides? No equal sides. Are you a fisherman, Corey? You ever gone fishing? When fishermen tell their stories, when they tell the story about what they caught, the fish starts out this big. The next time they tell the story, the fish is this big. When they get home and tell their wife, it's now this big, right? None of the stories are equal about their fish that they had to weigh on a scale. So maybe that'll, I don't know, maybe it's a stretch, but maybe it'll help you remember, Corey, if none of the sides are equal, it's a scalene triangle. There we go. Number 9, the sides of a triangle are 10 centimeters, 25 centimeters, and 25 centimeters. Elaine?
Isosceles.
Isosceles because
If the 2 are equal and 1 is different.
2 of the sides are equal. There we go. Number 10, the angles of a triangle measure 45 degrees, 120 degrees, and 15 degrees, Michael.
Obtuse triangle.
Obtuse triangle. Very good, because one of the angles is obtuse, greater than 90. For numbers 11 through 14, this had nothing to do with triangles, just a quick review of angles. A 95-degree angle, class, is?
Obtuse.
20-degree angle is?
Acute.
180-degree angle is?
Straight.
And 240-degree angle is a
Reflex.
reflex angle. Good. Flip back to page 165 and do 13 to 16. Page 165. Very quickly, do 13 through 16. Thinking through the different kinds of triangles. Michael's got him. Luciana's got him. Griffin's got him. Some people are being diligent to make sure they spell these things correctly. They're looking them up. Thanks, team. For sake of time, let's take a look at these. Number 13, angles of a triangle measure 30, 60, and 90. That's a very special triangle, by the way. You're going to learn more about that when you get to upper level math, 11th, 12th grade. That's actually the green triangle, by the way, that you see over there on the wall. It's been up all year. Has angles of 30, 60, and 90. It is obviously, Luciana, a right triangle. Number 14, the sides of a triangle measure 10 feet, 15 feet, and 10 feet. Bryson. What do we notice about the three sides? 10, 15, and 10. Well, they do add up to 35. It's true, but what do we notice about them compared to each other, maybe? There's two that are the same. And if two sides of a triangle are the same length, we have a name for that triangle. If two equal sides are there. Isosceles triangle. There we go. An isosceles triangle with two equal sides. What about number 15? The sides measure 25 centimeters, 25 centimeters, and 25 centimeters. Jalen.
Equilateral.
Equilateral triangle, because all of the sides are equal. If you put isosceles, would you be wrong?
No.
No, but we prefer the more specific term equilateral. But technically, isosceles is still true. Elaine, question?
No, I went.
You're volunteering for the last one. Okay. The angles of a triangle measure 60 degrees, and 60 degrees. Kirsten also had her hand up, and she was in the next row. So I'm actually going to go to Kirsten. Sorry, Elaine.
Equal angular?
Not equal angular, equiangular. E-Q-U-I angular. Equiangular triangle with all three 60-degree angles. And to Michael's question yesterday, if the three angles are equal, will the three sides also be equal? Yes, they will be. We'll prove in 11th grade geometry why that has to be true. But for now, if you were just going to keep that in the back of your mind, yes. However, when it gives you three equal sides, we're going to say equilateral, and when they give us three equal angles, we're going to say equiangular, remembering the definitions of the terms. Question, Ben?
So what's the difference between equilateral
and equiangular? It depends on what you're focusing on. If you're focusing on the angles as being equal, equiangular. If you're focused on the sides as being equal, equilateral. So it depends on what you're looking at. Does that make sense? All right. Turn over to page 166 again. And I want you to do 32 to 44. Page 166. Do the review section, 32 to 44. Reviewing over some concepts before we head into this Thanksgiving break. Students are excited. Keep it together though. Just, 3 more hours. 3 more hours and you got a week and a half of vacation, it will feel like.
Finally.
Yeah. Oh, you just had a vacation last week. Get off it. Veterans Day. You had Veterans Day off last week.
One extra day.
Yeah, that's enough.
I need a run.
I know you're excited about it. No, because we're trying to prepare you for real life, and in real life you don't get months off.
Well.
Unless you're unemployed and you're starving during your months off, you're not vacationing. Number 35, how many sides are on that figure, class? 12 different sides, right? They're all equal. By the way, that is an equilateral polygon because it's got all equal sides, right? It's called a duodecagon. Yeah, with 12 sides. You don't have to know that yet. You'll learn that when you get older. But duodecagon has 12 sides. It's an equilateral duodecagon. And so, yeah. Number 36 isn't really anything special, but it does have 4 sides. We all know what 36 would be called, class.
Quadrilateral.
Quadrilateral. You finish up in about 2 more minutes. Some of you are already done. Those who are still working, take about 2 more minutes, then we'll go over the answers. Good job, Lucia. Take about 30 seconds longer to be finishing.
I just realized that the sign for similar is like a tilde.
Yes, yeah. Do you want? All right, let's take a look at these. Number 32, what kind of angle is that, Ben?
Straight.
Number 33, Sam?
Oh, twos.
And number 34, Elaine.
Right.
So we have straight, obtuse, and right. Number 35, what is the perimeter of that equilateral duodecagon? Corey? 60 feet, very good. And number 36, we actually had to add these all together. What did you get for the perimeter of that weird-looking quadrilateral? Griffin?
27 yards.
27 yards is correct. Number 37, true or false? A hexagon has 5 sides. Kirsten?
Pentagon.
False, it's a pentagon. Number 38, Michael, the perimeter of a square equals 48 yards if a side is 12.
True.
That is true. Number 39, perpendicular lines never intersect. Luciana?
Parallel.
Parallel.
I am delivering more cans to more students and parents have brought off. Do you want me to send you an email with the students' names and how
That would be great, yeah.
I have more coming later today.
Yeah, we've already smashed our old record. Like, we're over 3,000 already, so yeah, keep it
Well, I'm
coming.
just delivering 10 more cans now, and
Yeah,
then I have
just-
another parent who said they're bringing more in.
Yeah, just email me whatever you got.
Okay.
Thanks, appreciate it. We are out of candy though, so this is just for the blessing, right?
Yes.
Yes. All right, so yes, parallel lines, number 39, never intersect. Number 40, if angle A is 122 degrees, angle B is 58 degrees, then those angles are complementary angles, Bryson. It does start with an S, but we're not looking for the word similar. Jalen? Supplementary, because they add up to, class, 180 degrees. Number 41, a reflex angle is an angle between 180 degrees and 360 degrees. Back to Bryson. True. Number 42, a trapezoid is a quadrilateral that has both pairs of opposite sides parallel, Sam.
True.
Trapezoid only has one pair of parallel sides, so it should be what, Ben?
Rectangle?
Well, you're not wrong, but you're too specific, because a rectangle also has right angles. This doesn't have to have right angles necessarily, Griffin. Parallelogram is what you were trying to say there. Number 43, the symbol for congruent is the equal sign with the squiggle on top. Class?
True.
That is true. And number 44, the symbol for similar is a squiggle equal over a regular line. False. What's the symbol for similar?
Tilde.
A tilde, or the squiggle. All right, but if you're going for the technical term, tilde is what you put over an N in Spanish to make it go ña. Español. You know the little. So anyway, it's called a tilde, but she's like, I just realized this is a tilde. Okay, great. I just say squiggly line, a little squiggle.
Yes.
But that works. That is perhaps a better way to phrase it. All right, no homework. Have a great weekend and a great vacation.
You too.